Okay, so we're going to go through sketching the equation shown. Working kind of left to right, we want to be able to pull out the information we need to so we can do this. 4 is the amplitude. 3 is the number of full cycles in 2 pi. So again, on the normal sine curve, our graph comes starting at 0, goes up, comes back down through pi and back up to 2 pi. So there's one full cycle starting up and then back down and back to the starting point. In that 2 pi. Now we're going to have 3 full cycles in that 2 pi. The plus pi over 3 here tells me I'm shifting left pi over 3. Remember that essentially we're looking at what do we need the x value to be to return me to the 0 position. So if this were all a 0, I'd have my x value 0. Now when I get negative pi over 3, that gets this middle part to 0, and so essentially what was here is now over here slightly. And then the minus 2, of course, just decreases the entire curve. So if all of this were hidden to me, then if that's my original y value, I'm simply subtracting 2 from that to get to my new position. So those are the actual numbers. The one question we sometimes are asked, or we need to sort of be sure we understand, is what is the period then? And the period, of course, is just what is the length of one full cycle. Well, if we have 3 full cycles in our 2 pi, then our period is that 2 pi divided by 3. And so what that tells me is, this will be a little bit rough here, 1, 2, 3, 4, 5, 6 and 2/3. So approximately right there is where my first graph will come back up through. And kind of, if I continue that same pattern, 1, 2, 3, 4, 5, 6 and 2/3 essentially there. I got 6 and 1/3 and 1/3 essentially there. So those are my division points for my 3 full waves. They'll come up and down through those points. So normally what I've suggested is I'm going to graph these 2 pieces of information first, and then I'm going to just kind of adjust my graph to indicate these. So I suggested yesterday this will be the rough draft of our graph, and of course if we needed to, we could recopy it and do a better job at that point. It's just the graph gets messy if we try to do too much perfectly first time. So there's my 2/3. Halfway between there is my 3 and 1/3. Over here, 3 and 1/3, that's about a 1/3, and 1, 2, 3. Oh yeah, of course, that makes perfect sense that halfway through my second graph we'll be hitting that point again. That's good. 1, 2, 3. And we do this as well as we can. Certainly I'm not asking you to do a perfect job measuring out when you have a number like 3. Obviously if we have quarters it's a little bit easier. That is not what I meant to do. To copy that and paste it. And we have essentially the same thing on this side of the graph. 1, 2, 3 and a bit. Now, what I know is my amplitude is 4, and so my graph has to go all the way up to 4. And again, this is where my graph has to come back down through and up to this point. So about halfway between there is where my 4 is. Halfway between there is where my negative 4 is. And so on and so on. Okay, so I've approximately lined up my the dots, and now my original graph again was starting at 0 and going up, and so if we draw this in, wow, that was nice. Okay, so as we fill this in, essentially this is what we see, and our graph looks basically like this. So again, this is now the amplitude and the 3 full cycles. You can sort of see pretty clearly. I have my 1, 2, 3 full cycles in this same section here, same sort of thing. My last two values, the shifting, I'll do sort of by indicating some key points on my graph. When I think about the fact that I have to shift left here, pi over 3, that means that this was negative 2 pi, which is essentially the same as negative 6 pi over 3. I need to go left another pi over 3, so I have negative 6 pi over 3 minus another pi over 3, which means this point would start at negative 7 pi over 3. And I'm simply going to go through and switch kind of these key points that were indicated previously to be whatever the new calculated value is. This one I'm not too concerned about, but negative pi for sure, sort of, where do I end up at this point? Negative pi minus pi over 3 is negative 4 pi over 3. Probably doing this in another color makes a little bit more sense. Negative pi over 2, I guess I could sort of do some of these key points. I don't necessarily have to do them all. This is negative pi over 3 clearly. Pi minus pi over 3 is 2 pi over 3. 2 pi minus pi over 3 is 5 pi over 3. And again, we're getting the basic idea down of what the graph is going to look like, with the idea that if I wanted to recopy it at some point, I could. So I have sort of those key points down. Take out that one, I guess. And then finally, of course, the last step, and this is one I guess we could debate. We could have done this as we were drawing the graph. The only thing is the sort of the shifting here that becomes a bit of a tougher thing to do all at once. Certainly I could have recognized that I was going to be dropping 2 overall, and this needed to only go this high. This needed to go down a little further if I had the room. My feeling is, again, at this point, this is as simple as anything is. And so I'm dropping the graph 2. So this is my 2, this is my 1, this is 0, negative 2, negative 3, negative 4, negative 5, negative 6. And of course, key points here would be maybe to indicate where the 0 is, where the 2 is, where the negative 6 is. If you really want to at this point, adding that in might even be fairly helpful. I suppose you could even add in the other axes if you saw it.